Terminal adapters conforming to V.120 can be used as a simple interface to workstations. The terminal adapter provides an asynchronous to synchronous conversion. Multiple B channels can be used in parallel. V.120 is not interoperable with Byte Synchronous links because V.120 does not provide octet stuffing to bit stuffing conversion. Despite the fact that HDLC and LAPB and LAPD and LAPF are nominally distinguishable, multiple methods of framing should not be used concurrently on the same ISDN channel. There is no requirement that P point-to-point protocol recognize alternative framing techniques or switch between framing techniques without specific configuration. Experience has shown that the LLC information element is not reliably transmitted end-to-end. Therefore, transmission of the LLC-IE should not be relied upon for framing or encoding determination. No LLC-IE values that pertain to P have been assigned. Any other values that are received are not valid for P links and can be ignored for P services. The LCP recommended sync configuration options apply to ISDN links. The standard LCP sync configuration defaults apply to ISDN links. The typical network connected to the link is likely to have an MRU size of either 1500 or 2048 bytes or greater. To avoid fragmentation, the maximum transmission unit MTU at the network layer should not exceed 1500 unless a PMRU of 2048 or greater is specifically negotiated. 2.6 X.25. This topic describes the encapsulation of IP over X.25 networks. In accordance with ISO/IEC and CCITT standards, IP over X.25 networks is documented by RFC 1356, which obsoletes RFC 877. RFC 1356 is a draft standard with a status of elective. The substantive change to the IP encapsulation over X.25 is an increase in the IP telegram MTU size, the X.25 maximum data packet size, the virtual circuit management, and the interoperable encapsulation over X.25 of protocols outside an IP between multi-protocol routers and bridges. One or more X.25 virtual circuits are opened on demand when datagrams arrive at the network interface for transmission. Protocol data units, PDUs, are sent as X.25 complete packet sequences. That is, PDUs begin on X.25 data packets boundaries, and the M-bit more data is used to fragment the PDUs that are larger than one X.25 data packet in length. In the IP encapsulation, the PDU is the IP datagram. The first octet in the call user data. CUD field, the first data octet in the call request packet, is used for protocol demultiplexing in accordance with the subsequent protocol identifier, SPI. In ISO/IEC TR 9577, this field contains a 1-octet network layer protocol identifier, NLPID, which identifies the network layer protocol encapsulated over the X.25 virtual circuit. For the Internet community, the NLPID has 4 relevant values. The value hex CC binary 11001100 decimal 204 is IP. CCITT recommendations I.465 and V.120 data terminal equipment communications over the telephone network with the provision for statistical multiplexing. CCITT Blue Book, Volume 8. Fast Cycle V 8.1, 1988. Point 2, The value hex 81, binary 100000001, decimal 129, identifies ISO/IEC 8473 CL and P. The value hex 82, binary 100000010, decimal 130, is used specifically for ISO/IEC 9542. ES-IS. If there is already a circuit open to carry CL and P, it is not necessary to open a second circuit to carry ES-IS. The value hex 80, binary 100000000, decimal 128, identifies the use of the IEEE subnetwork access protocol. SNAP, to further encapsulate and identify a single network layer protocol. The SNAP encapsulated protocol is identified by including a 5-octet of the SNAP head in the call request CUD field. Immediately following the hex 80 octet, SNAP headers are not included in the subsequent X.25 data packets. Only one SNAP encapsulated protocol can be carried over the virtual circuit opened using this encoding. The value hex 00 identifies the non-encapsulation used to multiplex multiple network layer protocols over the same circuit. RFC 3232 contains one other non-TCI-TT and non-ISO/IEC value that has been used for Internet X.25. Encapsulation identification, namely hex C5 binary 11000101.197. For Blacker X.25, this value may continue to be used, but only by prior pre-configuration of the sending and receiving X.25 interface to support this value. The hex CD binary 11001101.205 lists an RFC 2202 for ISO IP is also used by Blacker and can only be used by prior configuration of the sending and receiving X.25 interfaces. Each system must only accept calls for the protocols it can process. Every Internet system must be able to accept the TC encapsulation for IP telegrams. Systems that support NLPIDs other than hex CC for IP should allow their use to be configured on a per pair address basis. The non-encapsulation identified by a NLPID encoding of hex 00 is used in order to multiplex multiple network layer protocols over one circuit. When another encapsulation is used, each X.25 complete packet sequence sent on the circuit begins with a 1-octet NLPID, which identifies the network layer protocol data unit contained only in that particular complete packet sequence. Further, if the SNAP NLPID hex 80 is used, the NLPID octet is immediately followed by the 5-octet SNAP header, which is then immediately followed by the encapsulated PDU. The encapsulated network layer can differ from one complete packet sequence to the next over the same circuits. Use of a single network layer protocol circuits is more efficient in terms of bandwidth. If only limited number of protocols are supported by a system, it also allows each system to determine exactly which protocols are supported by its communicating partner. Other advantages include being able to use X.25 accounting to detail each protocol and different quality of service and flow control windows for different protocols. The non-encapsulation multiplexing is useful when the system value reason, such as implementation, restrictions, and other. Cost considerations can only open a limited number of virtual circuits simultaneously. This is the method most likely to be used by a multi-protocol router to avoid using an unreasonable number of virtual circuits. If performing IEEE 802.1d, building across the X.25 is required, Another encapsulation must be used. IP datagrams must, by default, be encapsulated on the virtual circuit. Open with CCC or COD. Implementations can also support up to 3 other possible encapsulations of IP. IP datagrams can be contained